Question 4, and we're on to centres of mass. Now I'm just going to set myself up a coordinate system using the lower left hand corner as the point 0, 0. And there we go. The other thing that I'm going to do is quickly calculate the centre of mass for that triangle. Now to do that I just need to find the average vertex, which is 1/3 of 0, 0 plus 0, 12 plus 8, 6, which is going to give me 8 on 3 and 6. Now the way in which I solve the first part of this question to find the x-coordinate of the centre of mass, if you like, because we're looking for the distance from AB of our centre of mass, so this our x bar distance, is to think about this in terms of compound shapes, because if I want to know where the centre of mass of my weird final shape is, I can do that by knowing where the centre of mass of my first shape is, subtracting the centre of mass of my second shape to give the centre of mass of my third shape. Now I do need to weight this by the weights or masses of the individual shapes, and because we're not told about the masses here, what we do is we assume the mass to be the area of the shape. So it's also going to be useful for me to know that 12 multiplied by 8 over 2 is 48, and that 4 multiplied by 4 is 16. Oops, let's tidy that up. And obviously if I do 48 take away 16 I get the mass of the final shape, which is going to be 32. So if I multiply the mass of the shape by its centre of mass, which in this case is 8, 1, 3 and 6, and I subtract the mass of the shape multiplied by its centre of mass. Now all I know about the centre of mass for the square currently is that it is a distance of 2 in from the line AB. I don't know what the y-coordinate of that centre of mass is, so I'm just going to leave that there as a question mark, and that's going to be equal to 32 lots of the centre of mass of the whole system, x bar, y bar. Now as I say, we're only interested here in the x coordinates, so let's just do 48 multiplied by 8/3 minus 16 multiplied by 2 is equal to 32 x bar, which tells me that 96 is equal to 32 x bar, or that x bar is equal to 3. So here I have my answer for the first question, which is 3 centimetres. Now we're going to freely suspend the object from the point A and let it hang in equilibrium. Now what do I know about a shape that hangs in equilibrium? Well, I know for absolute sure that its centre of mass will definitely be directly below the point of suspension. So if I'm suspending from the point here A, then my point G is going to be vertically below A. We're told that AB is now at 25 degrees to the vertical, so I know that the angle to the vertical here is going to be 25 degrees, and by the fact that I've got now 2 parallel lines, I know also that the angle in here is going to be 25 degrees. In fact, I know even more than this. We worked out in the first part of the question that the distance of G from AB, this distance across here, is in fact 3 centimetres. Putting all of that together, if I know that the angle is 25 and that the length here is 3, I can work out this distance here, which is going to be D is equal to 3 divided by tan of 25. And this is great news to us, because now if I go back to this system, I know that the centre of mass is a distance of D below A. Well, what else do I know? I've earlier indicated that the centre of mass of my system is going to be at x bar, y bar. We know that x bar is 3. What do we know about y bar? Well, actually we can now calculate where y is. Now y is a measurement up from 0. And I've just worked out that the centre of mass must be a distance of D down from A. So I know that y bar must be this part that's left in between, which is going to be 12 minus D. So y bar must be equal to 12 minus D. Where are we going with this? Well, we want to find the distance of O from DC. Now O is the centre of mass of the square. I'm actually going to go back and use this equation that we had written out earlier. And this time I'm going to use the y coordinates, because I know that 48 multiplied by 6 minus 16 multiplied by whatever the y coordinate of O is going to be equal to 32 multiplied by y bar. And now I know what y bar is. Y bar is equal to 12 minus d. So rearranging, I know that 48 multiplied by 6 less 32 lots of 12 minus d is equal to 16 lots of whatever this coordinate is going to be. Dividing 3 by 16, that's 3 lots of 6 less 2 lots of 12 minus d. Now d we have down here, which is 3 on 25, tan 25. And that's going to be equal to whatever this y coordinate is here. Now, in doing that, I found out that my answer is 6.867. So I now know that the y coordinate in my diagram here is going to be 6.867. What did I actually want to calculate? Well, the question was asking me for the distance of O from the line DC. So what I'm interested in is how far is this point above this line DC. Well, I know it's a total of 6.867 above 0. I know that the line DC is halfway along, so all I need to do to complete this is subtract 6 from my answer to get my final answer for part B, which is going to be 0.867.